Okay, the last video from this topic will be about energetic competition, and this is a big, important topic, though it's not quite as challenging as some of the other ones. So let's get into it. Electron acceptors and electron donors really determine how much energy organisms can get, because electron acceptors that are good at accepting electrons potentially give the cell more energy than electron acceptors that are not quite as good at accepting electrons. So oxygen is the best, and that is really why so many different cells use it. But again, it's not the only one. And so in places where there's no oxygen, other alternatives are looked for and used. So there are a lot of places without oxygen. So your large intestine, for example, the lumen of your large intestine has no oxygen at all. There's not even very much oxygen within your tissues outside of your bloodstream and places it can reach. So a wound, if a person has like a wound, a deep wound, the inside of that could be free of oxygen. So if the environment has several different potential electron acceptors, which one will be used first? Which organisms are going to win? Because if some specialize in using nitrate and others specialize in using sulfate, they're going to compete. And so if the environment has both, who's going to win? Well, if some cells can only do the nitrate reduction and some can only do sulfate, it's the one that can use the best electron acceptor. That's the one that's going to win. So the electron acceptor that is best at accepting electrons gives that organism the most energy. And in this case, that turns out to be, well, we'll see, that turns out to be nitrate. And cells will use up all the nitrate and all the other resources. And only once that's gone, and those cells can no longer use up resources, that's when cells that can do this will start to grow and do this. So in the environment, you would see nitrate get used first, and then sulfate. So that's what we see. Oxygen gets used first, then nitrate gets used, then sulfate gets used, if they're all there. So that's what this all says. One of the last things that happens after the sulfate gets used up and all the other good electron acceptors are gone, eventually carbon dioxide is used as an electron acceptor, and it is terrible. But that's what leads to formation of methane as its waste product. So the organisms called methanogens get a tiny amount of energy from using carbon dioxide as their electron acceptor and generating methane as their waste product. So this is this is a slide that shows the major electron acceptors and their hierarchy. So by far the best is oxygen, and organisms that use oxygen win whenever oxygen is present. Once oxygen is not present, these two are just about equivalent. Nitrate, and this is ferric iron, this is like rust. These two are the best of the other alternatives. Once these are gone, these really terrible electron acceptors are the only things left. So sulfate is present in the environment in many places, and it's very common for it to be used, but only after oxygen and nitrate are used. Carbon dioxide is ubiquitous in the environment, and it gets used if none of these are available. And so in places with very little oxygen, that's when we see hydrogen sulfide and methane. Both of those come out of a human gut. Both of those come out of lake sediments. Any really oxygen-free environment ultimately will start generating these gases as bacteria use these molecules as their terminal electron acceptors in respiration. Of course, fermentation is typically way worse than using respiration using oxygen. And it's usually worse than using nitrate as an electron acceptor. So if nitrate or oxygen is present, those will get used, and organisms that can use those through respiration will win. If those aren't available, then fermentation will compete with anaerobic respiration using these electron donors. So fermentation systems would generally be down here in terms of how much energy they create for a cell. So that was, that's competition for electron acceptors and how it works in the environment. And we can see this in many environments. You can just see in sequence, oxygen goes away, then nitrate goes away, then sulfate starts to go away as fermentation starts to happen. And ultimately, looking at a cell as a thing that needs an electron donor and electron acceptor can help you understand the nitrogen cycle and the sulfur cycle and these big things that happen in the environment that really affect us. Oxygen only exists because plants and cyanobacteria make it as a byproduct when they steal electrons from water. And that's a crazy thing, and I'm happy to go into more detail about that, but I won't here. So that's plenty. The rest of the slides are curiosity slides, and they're cool. One of them is about a clinical situation where this exact thing is very important. And what we find is that when organisms switch from using oxygen to using nitrate or any of these, they typically become resistant to many antibiotics. And that can happen inside a biofilm. If there's no oxygen in the biofilm, the bacteria will be using something like this to get energy, and they become resistant to antibiotics. So this does have a lot of clinical relevance, even though in the day-to-day work of a clinician, they wouldn't necessarily think about it, but it does drive a lot of bacterial infections. So thanks for your attention to this, and now you know one of the most important forces driving change in the environment. So with that, I will see you later.